can see about cyclic subgroups. So here is one example is there. 4 cyclic subgroups can be made from a group G equal to Z6 and the binary given is addition. Okay, so what does this indicate? Z6 means a group consists of 6 elements and we are going to perform the binary operations addition. So this is the meaning. A group is having 6 elements and we are going to performing additions. Okay, so the group consists of elements are 0, 1, 2, 3 and 4 and 5. That means we are having 6 elements are there. So here we are going to perform an modulo 6 as an operation. Now we are going to create a cyclic subgroup. Okay, a cyclic subgroup is generated by an element G such that the subgroup can be generated by G, 2G, 3G, 4G and so on for the modulo 6. Why modulo 6? Because we are having 6 elements in this group. Now we need to calculate the subgroups. The first subgroups, this meaning if we are having G, okay, G and the second value will be 2G, that is G, the binary value given is addition. So 2G's, we are going to add 2G. Then 3G, that means G plus G plus G. 3G, we are going to perform the addition operations. Okay, so for the first subgroup, we need to find the first subgroup. The first element will be equal to 0. Okay, so from this, the first element will be equal to 0. So what is G? That is 0. Then 2G, 0 plus 0. So all the values will be equal to 0. So the subgroup H1 will be equal to 0. Now coming to the second subgroup, the second element. What's the second element? That is 1. So that is G for the second subgroup, G equal to 1. So what we can do, the first one is G and then 2G, 1 plus 1, then 3G, 1 plus 1 plus 1 and so on. And this process goes until the values goes to 0. Okay, so first G, this is G1, then 1 plus 1 that is 2, then 1 plus 1 plus 1 that is 3, then 4 and 5. When we are adding 6 ones, this will be equal to 0 because this is modulo 6. Okay, so when it became 0, we will stop. So this subgroup having the values 0, 1, 2, 3, 4 and 5. 0, 1, 2, 3, 4 and 5. This is the second subgroup. And this is also called as the generator. Why this is called as the generator? Because when creating some subgroups, it will create the same elements in the main group. Okay, so we know that the main group having the values 0, 1, 2, 3, 4 and 5. The subgroups also have the same values. So this is called as the generator. Okay, similarly the next element H3 equal to 2. Okay, so here G equal to 2. So what we need to do? First G equal to 2. Then 2G, that is G plus G, that is 4. Then 3G, 2 plus 2 plus 2, that is 6, which will be equal to 0. Okay, so what are the elements in the subgroup? 0, 2 and 4 are the elements in the subgroup. Similarly, the next element in the main group is 3. So 3, that is G, G plus G, 3 plus 3, that is equal to 6. So only 2 elements in the subgroup 4. So the 4 cyclic subgroups of the given problem is that 6 are 0, 0, 1, 2, 3, 4, 5, 0, 2, 4 and 0 and 3. So this is the cyclic subgroups created by the main group. Similarly, we can look into another one example, that is group G equal to Z10 star X. So what does this indicate? This indicates we are having a group having 10 elements. What does this star? This is the co-prime factor. Co-prime factor of 10 elements we are having. and the binary operator we are going to use multiplications. Okay, so the group consists of integers less than 10 that are co-prime with multiplication modulo 10 as the operations. The elements of G are 1379. How it comes? Let's look into that. So we need to find the prime factorization of 10. How will you find the prime factorization of 10? That is 10 equal to 2 cross 5. Thus an integer is not divisible by 2 or 5 will be a co-prime to 10. First we need to find the numbers which are divisible by 2 and 5. We know that the number less than 10 is 1, 2, 3, 4 and up to 9. Okay, so from this the number divisible by 2 is 2, 4, 6 and 8, and the number divisible by 5 is only 5. So the remaining elements are called as the co-prime factor of 10. So the remaining integers, what are the remaining integers? That is 1, 3, 7 and 9. So the remaining integers are 1, 3, 7, 9. So then the main group for this G10 star multiplication is 1, 3, 7 and 9. Okay, so from this main group we need to create a subgroup, cyclic subgroup we need to create. Since this is a multiplication operator, the terminology change, that is the subgroup can be generated by G, G square, G cube. In the addition we use G, 2G, 3G, here G, G square and G cube. So these are all the step by